Albert Einstein, 1879 to 1955. The greatest physicist since Newton introduced a universe in which time, space, and gravity are relative. Still can't see how he thought of it. The physicist Richard Feynman once said of Albert Einstein's theory of general relativity, and whereas Feynman himself was no slouch in the brilliance department, it's easy to understand why he felt that way. Before Einstein, physicists thought of gravity as a force of attraction between two objects, as most laypersons think of it today. Einstein showed instead that gravity is better understood as the idea that massive objects, stars for example, create warps in an all-encompassing entity known as space-time, much as a cannonball depresses the surface of a trampoline. Roll a marble nearby and it spirals in, not because the cannonball pulls on it, but simply because the marble gets trapped by the depression. It sounds bizarre, but Einstein's counterintuitive vision of gravity works better than Newton's to explain the motions of planets, stars, and galaxies. Not bad for a young German Jew who couldn't find a teaching job after graduating from the Polytechnic Institute in Zurich, Switzerland, at the turn of the 20th century. Einstein ended up as a technical examiner for the Swiss Patent Office, where he began thinking in depth about something he'd first wondered about at age 16. How would a beam of light appear if you could chase it at high velocity? Unlike what you'd see if you chased a speeding train, he eventually concluded, the speed of the light beam should appear to be exactly the same whether an observer is traveling toward or away from it. Starting from that premise, Einstein concluded that both time and motion are entirely relative and that the phrase at rest is meaningless. He further showed with mathematical rigor that nothing with mass can ever reach the speed of light, and that the light particles known as photons must be massless. Another implication, matter and energy can be transformed one into the other, the meaning of history's most famous equation, E equals mc squared. The paper he wrote on what he called the theory of special relativity in 1905 made Einstein instantly famous, but another paper he wrote that year on the so-called photoelectric effect was equally important. It provided a foundation for quantum theory. Einstein would ultimately become dissatisfied with quantum physics because it implied a totally probabilistic universe where some things could never be known. He went on to publish the theory of general relativity in 1916, eventually fleeing the Nazis along with other Jewish intellectuals and settling at the Institute for Advanced Study in Princeton, New Jersey. His last great idea, the unified field theory, which he hoped would unify electromagnetism and gravity within a single theory, appeared to be misguided, although its tenets are enjoying a renaissance today. In his later years, Einstein became better known to the public as a frizzy-haired, sad-eyed, grandfatherly pacifist. To scientists, however, he will always be a world-class revolutionary, the man who left Feynman and the greatest physicists of the 20th century shaking their heads in awe.